Friends, good morning everyone. My name is Sheikh Rahman. I am from Civil Department. At present working in Angrove Engineering College. So from Kodad. So today in this section we are discussing about the third unit related point of nothing but of the groundwater hydrogeology. The course related third unit segment point of third unit related topic is nothing but Jacob's implications. So groundwater hydrogeology related third unit point of Jacob's implication related topic today we are discussing about. So let me start our section today detailedly discussing about the Jacob's implications. So here we go. So Jacob's implications, nothing but of the, first of all, this implication before the Thais equation will be there. Nothing but of the water flowing in unsteady flow of water, unsteady of water flow in aquifers point of the Thais giving a equation, non-equilibrium equation will be given. So that equation they have to be modified according to Thais point of, the equation may be that represented graph has to be having some curve, little bit curve. So what is Thais equation? Nothing but of the S is equal to Q by 4 pi T into WU. S is equal to Q by 4 pi T WU. So nothing but that equation point of maximum we are getting some curve ratio according to time base and also U point of well functioning W well functioning point of we draw a graph, that graph represented by the curve. So but that curve should be modified by the Jacob's applications point of Jacob did some work to has to be maximum avoid that curve. So here they represent that line. Jacob suggested method which completely avoid the curve. So that particular point of Jacob take the parameters or nothing but of the when R is small, the same time T is nothing but of the discharging of the water time is also large. So U nothing but well function may be small. So when the R is small, T is large, or the well function of the W in that U E may be small. So hence all the terms of second terms of the series is point of, so he should be explained one equation. Nothing but of the Thais also propose the equation as mathematical point of mathematical integration point of S is equal to minus 0.5772 minus log base C U plus U my U minus U square by 2 into 2 factorial. So plus U cube by e to the power of q e to the power of 3 by 3 into 3 factorial. But in the maximum here not factor not mentioned. So particularly S is equal to my Thais equation point S is equal to minus 0.5772 minus log E base C U plus U minus U square by 2 into 2 factorial plus U cube by 3 into 3 factorial. So in this case W may be neglected. Why? Because of U may be small, especially but particularly the equation point of 0.001. It is represented by the 0.001. So that particular point of maximum here should having negligible. When V is very small, we are negligible. So then the W is equal to minus 0.5772 minus log base CU we represented nothing but of the W represented by the well function. According to the Thais equation point of at the same time of Jacob equation point of also be W is nothing but of the well function. My dear students, what I am saying here, nothing but the basic equation is nothing but Thais equation. The Thais equation is should be represented, which should be modified, assumption modified and simplification done by the Jacob. So that's what we are called Jacob simplification. I think but what he did here maximum to what having some curve will be there for Thais equation point of the Thais equation having curve should be modified, completely neglected, completely removed as possible as he has to be making a straight line. So according to that particular point of S is Thais equation S is equal to Q by 4 pi T into W, but here also say the Thais equation also given in mathematical point of S is equal to minus 0.5772 minus log e u plus u minus u square by 2 to 2 factorial plus u cube by 3 to 3 factorial. So according to that particular point of this particular point of w is nothing but of the well function. So s is equal, simply we are saying 0.5 minus 0.5772 minus log e u. So nothing but of the here u is equal r square s by 4tt. So u is equal r square s by 4tt. So nothing but of the u is well function point of r square is nothing but of the radius of the well. So s is nothing but of the drawdown value, nothing but of that for 4 t is dependent by the transmissivity of the well, and also t is nothing but of dependent by the time. So next, so Jacob simplification point of s is equal to see here equation s is equal q by 4 pi t, w place we are replacing by the log e 4tt by r square s minus 0.5772 according to my equation point of divided by the r. So nothing but of this is equal to q by 4 pi t, w point of already we are mentioned that the mention already w place we are represented by the 0.5772 log log e base u. So like that. So here also nothing but of the s is equal, according to Jacob's equation point of s is equal q by 4 pi t log e 4tt by r square s. Nothing but of the w point of it has to be modified 4tt by r square s. So here minus 0.5772 and the number one equation r1. So if you are repeating r1 equation, so for the sum observations well, if S1, S2 are the observed drawdowns at the time T1, T2 since pumping started. Particularly the well will be there. First of all, the observation of the well S1, S2 are dependent by the drawdown values, and T1, T2 to nothing but the time pumping started or pumping starting time. So here having drawdown differences is equal to nothing but S2 minus S1. So S1 is nothing but of the less shortest having by the nothing but more drawdown. S2 after recharge point of having less drawdown. So particularly the mustn't we should be identified or calculated by the drawdown difference according to Jacob's point of delta s. The difference of the drawdown values delta s is equal to S2 minus S1. That mathematical point of representing value is 2.303 q by 4 pi t log 10 t2 by t1. So nothing but of the according to Jacob's implication point of he given the equation s is equal to q by 4 pi t log e 4 capital T 4 into capital T into small t by r square s minus 0.5772. Nothing but where we get this 0.577, nothing but according to Theis equations point of. So for the some observation of the S1, S2 are the observed drawdown at the time 1, time 2 since pumping started. Okay, he have the drawdown differences, particularly for example time 1 having drawdown values one type of meters after some time represented by the T2. That particular point of drawdown values should be changed. T1 time drawdown value S1, T2 time drawdown value is represented by the S2. So mustn't having by the T1, T2 having some of the time happy pumping will be happening. The water levels should be changed in that aquifer, in that well. So automatically that drawdown differences will be existed. The drawdown differences has to be calculated by the Jacob equation point of delta S is equal to S2 minus S1 is equal to 2.303 q by 4 pi t log 10 t2 by t1. So these particular mathematical representative point of he has to be implemented this particular 2.303 q by 4 pi t. But according to the Theis point of q by 4 pi t only, but 2.303 that implementation of that adding by the that inside by that has to be added by the only Jacob here. Okay, so next that graph represented by the we are taken by the horizontal point of your time, nothing but already I discussed T1 T2 time values. T1 T2 time values will be represented by the horizontally. Vertically what having drawdown values will be maybe increasing or decreasing point of whatever it may be. That vertical axis point of we are taking by the that vertical axis point we are taking by the vertical axis point of drawdown values, horizontal point of the x-axis point we are taking time values. So these time values based on that drawdown values should be changed. Time will be changed automatically. Drawdown vertical drawdown values also be changed. So x-axis point of we are taking represented by the time values 0.2, 1, 10 like that. Y-axis point of 0, 5, 10, 15, 20, 25 meters of drawdown of the that particular of the well, that particular of the aquifer. So maybe based on the time the time represented by the drawdown values will be represented a graph. That graph should be plot a straight line. So but the ice equation point of same this graph is represented by the like curve. I think projectile curve point of have to be represented by the ice equation point of that curve should be modification point of reducing point of Jacob given some simplifications. According to simplification point of that Q will be into it will be multiplied by the 2.303 2.303 will multiply. Automatically we are getting some straight line formations. Okay, so next one. So its plot is made up between S nothing but drawdown and then for the long cycle of the time difference T2 is equal to 10 and T1. We get nothing but of that particular point of what the given equation point of here particularly. So that particular point of nothing but here given nothing but so nothing but delta S is equal to S2 minus S1 2.303 Q by 4 pi T log 10 T2 by T1. Get nothing but T2 is equal to 10 into T1, nothing but 10 into T1. So automatically T1 cancel, log 10 into 10 automatically divided by the entire of the log 10 T2 by T1 divided by the one value. So that we are represented in slide 5. So it is a plot made of between S and then for the one long cycle of the time differences. So T2 is equal to 10T we get. So automatically delta S is equal to S, nothing but the drawdown differences delta S is equal to S2 minus S1 2.303 Q by 4 pi T. So I told now that log 10 T2 by T1 the entire that particular portion nothing but given by the 1. So 1 into 2.303 Q by 4 pi T is same value. So that should not be changed here. So automatically if we required transmissibility nothing but the aquifer transmit a well transmitted point of, so we require T only, you require with T. So that T have to kept decide automatically 2.303 Q by 4 pi delta S. So nothing but of that driven by the transmissibility of the well. So extra plotting the straight line the curve to intersect with the zero drawdown axis permit the calculation for the S led to the time since pumping started at which the drawdown is observed well is still 0. So nothing but of the when we are starting of the pump starting time after some time essential zero drawdown well is nothing but of the ultimately the depression curve drawdown curve meet to the initial level of the water level, then automatically observation well is still 0, nothing drawdown is 0. Pumping is started nothing but since pumping started time drawdown is 0, drawdown values also S is equal to 0, time also 0. Why? Because of we not pumping started. So because of T is equal to 0, S is equal to 0. So that will be based on that S and T is 0 point of, then equation is equal to Q by 4 pi T log E T cap 4 T by R square S minus 0.5772. So S is equal to 0. So automatically Q by 4 pi T log E 4 T not 0 by R square S is equal minus 0.5772. The S is equal to 0 value and T is equal to 0 value represented here. Substitution in this case S is equal to 0. So okay, we are satisfied. Q by 4 pi T log E 4 T small t 0 by R square S minus 0.5772 as it is. So automatically log E 4 T naught by R square S is equal 0.5772. So as particular entire portion is equal 0 particular point of automatically. So the entire of the nothing but of the this particular portion has to be. So write like this here. So log entire this is nothing but it will be there in into. Okay, it will get here maximum, but it will be there in by. So automatically 0 by everything will be 0. So entire q by 4 pi t value is getting to 0. So I accept the remaining of the log e 4 t naught by r square s minus 0.5772. So automatically 0 is equal, this entire portion will be 0 na? So automatically 0 is equal log e 4 t naught by r square s and minus 0.522 there. So we want to be change this position. So automatic entire of the log e 40 t naught r square s come this side, automatic minus log e 40 t naught by r square s. So here having only minus 0.5772. Minus is minus cancel, and finally we are getting for having by the log e 40 t naught by r square s is equal 0.5772. So here maximum 40 t naught by r square s having log e is into formation, that will be sending to the e to the power of 0.5772. So automatically 4 t naught by r square, so is equal s into e to the power of 0.5772. So we required only s, nothing but already we are knowing about the t. Now we are required by the s value. S is equal, only kept the s that particular place. So s is equal 40 t naught by r square into e to the power of 0.5772. So nothing but of the already we are learning, we are knowing about the t value is t is equal 2.303 q by 4 pi delta s t well transmissivity. So according to the equations are there nothing but when the t is equal to 0, s is equal to 0 at the starting time of the aquifer and pumping well. So automatically then s is equal 4 t naught by r square e to the power of 0.5772. So nothing but of the this simplifications point of, so Jacob simplification point of t is equal 2.303 q by 4 pi delta s. And at the same the Jacob equation point of s is equal nothing but of the stoichiometrity is s is equal 4 pi t naught by r square into e to the power of 0.5772. So this is the simplification of that one. So s is equal 4 t naught by r square into 1.78 because of log e to the power of 0.5772 will be there na, that we have converted as 1.782. So finally s is equal 2.25 t naught r square, nothing but of the s, so it will be represented. Note the storage coefficient s can be calculated from the equation R2. The straight line approximating this, the method should be restricted to the values less than the 0.01, avoid large errors. Maybe the u value will be there 0.0 only, then it will be applicable. Otherwise this t and s value is not able to applicable for finding of the unsteady flow of the water in the aquifer point of. Okay, so let me conclude this section. So my dear students, I hope you understand everyone. Please, if you have any doubts, because of it is a problematic content topic, so if having any doubts, please text me as possible as I reply to you. So we will meet in next section. Thank you very much.